Hello girls, I hope you're having a great day and you're staying safe at home. Now coming to the last part of organic chemistry after your reduced syllabus, the last hydrocarbon we are going to talk about are alkynes. You know, alkynes are hydrocarbon that has a triple bond which is known as acetylynic bond between two carbon atoms, as you can see here, and they are unsaturated because of the triple bond between the two carbon atoms. They form a homologous series with a general formula CnH2n-2. A quick look at the homologous series of alkynes. Okay, first we have ethyne, which is also known as acetylene, C2H2. This is the condensed formula and this is the structural formula. Next we have propyne, which is also known as allyline. This is the condensed formula and this is the structural formula. Next we have butene, which is also known as crotonylene. This is the condensed and this is the structural formula. And finally we have pentyne, which is also known as propylacetylene. Okay, and this is the condensed formula and this is the structural formula. Okay, the sources of alkynes, we find alkynes in natural gas and petroleum. Now, moving on to isomers of alkynes, you know that alkynes with 4 or more than 4 carbon atoms can form isomers. They show both position as well as chain isomerism. As you can see, butene shows position isomerism. Position isomerism means where the triple bond is situated. So here you can see it is situated in the first carbon atom, and here it is situated in the second carbon atom. So you have but1 ine and but2 ine. Now talking about ethyne or acetylene, the general formula or the molecule formula is C2H2. It is the first member of the alkyne series, as you can see here. It has 2 carbon atoms with a triple bond between the 2 carbon atoms. It is unsaturated. Since it is unsaturated, you will not find it free in nature. The sources of ethyne you'll find in coal gas and in gases, which is obtained by the decomposition of certain very complex organic compounds. Okay, it is also obtained by cracking of alkanes from various fractions of petroleum. Now, if we take a look at the structure of acetylene or ethyne, you will see that each carbon atom in acetylene is attached to one hydrogen atom with a single bond, okay, and then there is a triple bond between the 2 carbon atoms. So the shape of ethyne molecule is linear. Moving on to the laboratory preparation of acetylene, okay, you can see the apparatus here. You arrange the apparatus in this way. In a conical flask, you take calcium carbide and through a thistle funnel, you pour water dropwise over the calcium carbide. Okay, and then there is a bent delivery tube leading over a gas jar which is inverted over water. In the beginning, this gas jar is full of water. Okay, so when the reaction sets in between calcium carbide and water, calcium hydroxide and acetylene will be formed. So acetylene is a colorless gas which passes through the delivery tube and passes over the water and bubbles into the inverted gas jar, and it is collected by the downward displacement of water. You know the reason, because acetylene does not dissolve in water. It is insoluble in water. So this is the reaction, the equation: calcium carbide plus 2 molecules of water. You will get 1 molecule of calcium hydroxide and 1 molecule of acetylene gas. Okay, so I already told you the gas is collected by the downward displacement of water since it is insoluble in water. Now remember, calcium carbide is not pure. It is contaminated by calcium sulfide and calcium phosphide. As a result, together with acetylene gas, you will get impurities like phosphine, hydrogen sulfide, ammonia and arsenic. Okay, so what happens when this gas passes through water? All the impurities except phosphine are absorbed. Okay, phosphine is absorbed by passing it through acidified copper sulfate or acidified potassium dichromate solution. Please do not forget that. And another thing you must remember is that the flask should not contain any air, as acetylene forms an explosive mixture with air. The air of the flask is displaced using oil or gas. Now, another way of preparation of acetylene is from 1,2-dibromoethane or ethylene dibromide. So you see here, when 1,2-dibromoethane, also known as ethylene dibromide, is boiled with alcoholic potassium hydroxide, what is formed? Ethyne is formed. And remember, the temperature is 200 degrees Celsius and it must be boiling. Okay, so ethyne is produced together with potassium bromide and water. You will get 2 molecules of potassium bromide and 2 molecules of water. Next, we move on to the properties of acetylene. Physical properties. Acetylene is a colorless gas with an ether-like odor, sweet odor. When it is pure, the one prepared from calcium carbide has a garlic odor. You know why? Because there are traces of phosphine and hydrogen sulfide, and it is negligibly soluble. Negligibly, you know, means very less. It is so less that you can even ignore it, but it is highly soluble in organic solvents like acetone and alcohol. Please remember the organic solvents in which acetylene dissolves, because it will be important in your section 1 of the question paper. It is lighter than air. It liquefies at minus 84 degrees Celsius and its boiling point is minus 75 degrees Celsius. Okay, moving on to the chemical properties. Ethyne is a highly reactive compound due to the presence of a triple bond between its 2 carbon atoms. That is why it is not found free in nature. Now, oxidation of ethyne means combustion or burning of ethyne. That is, when oxygen is added, things burn, isn't it? So in the same way, ethyne also burns in the presence of oxygen. Ethyne contains a great proportion of carbon content than alkanes, ethane, or alkenes, ethene. Since all the carbon particles do not get oxidized completely, it burns with a sooty flame, black colored flame, because lots of carbon molecules are produced. So ethyne burns in excess air, but if it gets lots of oxygen, it burns with a brilliant white flame to produce carbon dioxide, water vapor and a large amount of heat. So this is the reaction of oxidation of ethyne, or combustion or burning. With oxygen, it forms carbon dioxide, water vapor and lots of heat energy is given out. Next, we come to addition reactions. Alkynes, you know, are unsaturated due to the presence of the triple bond. So they are associated with addition reactions because the triple bond easily breaks up. The breaking up of a triple bond gives another product which is still unsaturated, that is a double bond. Okay, again it breaks up further and finally it gives a saturated product. So you can say from alkynes to alkenes and finally alkanes will be formed. Okay, so when hydrogen is added, it is known as catalytic hydrogenation. Why catalytic? Because it requires a catalyst. So in the presence of nickel, platinum or palladium, ethyne first takes up 2 atoms of hydrogen to change to ethene, which further takes up 2 atoms of hydrogen to give ethane. So this is the first stage of reaction, ethyne and hydrogen. Which catalyst is taken here? Nickel. So what is formed? Ethene is formed. So in the first stage, ethene is formed, and in the second step or the second stage, the ethane will take up one hydrogen molecule in the presence of nickel as the catalyst, and ethene is formed. So here you can see how ethene takes up one molecule of hydrogen, nickel as the catalyst, and forms ethene, which again takes up one hydrogen with nickel as the catalyst and forms ethene. Okay, next reaction is addition of halogen, reaction with chlorine. Ethine is an inert solvent like carbon tetrachloride. For example, adds chlorine to change into an ethene derivative with a carbon-carbon double bond. The triple bond breaks up and a carbon-carbon double bond is formed first, and then an ethene derivative is formed with a carbon-carbon single bond. So here you can see acetylene ethine chlorine, first one bond breaks up and forms a double bond between hydrogen, and again another chlorine molecule is taken up and acetylene tetrachloride or 1122 tetrachloroethane is formed. So here you can see there is a single bond. So first the triple bond breaks up and forms a double bond, and then the double bond breaks up to form the single bond. So acetylene reacts vigorously with chlorine gas in the presence of sunlight to give out flames. So the reaction is very vigorous. It also bursts into flames. So this is the condensed reaction. You can see acetylene reacts with chlorine to form carbon and hydrogen chloride. Okay, so reaction with bromine. When bromine in carbon tetrachloride is added to ethine, its brown color disappears. Okay, you may get this question in what is your observation when bromine is added to ethine. So what will your observation be? Brown color disappears. Okay, if you ask the reason, due to the formation of addition products. Okay, so it is similar to the addition of chlorine that we just discussed. So ethine, you can see one molecule of bromine turns into acetylene dibromide. Again, one molecule of bromine turns into acetylene tetrabromide. Next we come to reaction with iodine. We are talking about the reaction of ethine with halogens. So that is why we are talking about chlorine, bromine and iodine. So iodine reacts very slowly with ethine in the presence of an alcohol to form diiodo derivative. So the triple bond breaks up to form a double bond, and it is 1,2-diiodoethane. Now next, moving on to reaction with hydrogen chloride or hydrochloric acid. In this case, ethine reacts with hydrochloric acid to first form chloroethene and finally 1,1-dichloroethane. If you have noticed in all the reactions that I have been telling you here, first the triple bond breaks up into a double bond, and then the double bond breaks up into a single bond. So here acetylene with hydrochloric acid, the triple bond is breaking up and forming a double bond, that is chloroethene is being formed. Again, chloroethene reacts with hydrochloric acid to form, so from double bond a single bond is formed, that is 1,1-dichloroethane. Okay, so uses of ethine: it is used for oxyacetylene welding at very high temperatures. How do we get these high temperatures? We get it when ethine burns in oxygen. It is also used as an illuminant in oxyacetylene lamp. Illuminant means which gives the bright light. It is also used for artificial ripening and preservation of fruits. If you remember, acetylene is the only gas plant hormone. Okay, it is also used for the manufacture of synthetic products like polymers, artificial rubber, oxalic acid, and it is also used for the important organic compounds like manufacture of important organic compounds like acetaldehyde, acetic acid, plastic and rubber. Okay, children, on this table 17.6 Okay, I don't know whether you are using the same edition as me. Okay, if not, please check. This is at the end of your alkynes chapter. Okay, the chemical test to distinguish between alkenes and alkynes. Go through this, and your assignment for today is to write down the chemical properties of alkynes and submit it on Friday, that is 17th July at 11 o'clock in the morning, in my personal number in WhatsApp. Till then, children, have a great day.